Hi guys, today we are going to learn binary search. Okay, so I have already created an array. Okay, which contain the 0 to 10 means 11 elements. Okay, so first of all, for the binary search, array should be, or you can say, array must be sorted. Okay, so we will in this concept we will for the searching we will divide the array through left or right indexes by 2. Okay, so just let's start. So let we are going to check, uh, let me check, uh, 81. Okay, so 81, we need to check means, uh, this is the x equal to 81, we need to check. So first, we will mark this 0 index is left. Okay, 0 index is left, and the last index is right. Okay, and uh, we need to check here, what will be the middle. The middle, left plus right by 2 is will be the middle. Okay, so left is 0 plus 10 by 2 is 5. Middle is the 5 index, so 22. This is the middle. Okay, and now we need to check this, middle element is less than or greater than to the search element. So here 81 is greater than, means middle element is less than 81. Okay, so in this case we don't need to search from 0 to 5. We know the searching element is uh, uh, belong to this part. Okay, so we need to shift left from here to here, means left will be the left will be the m plus 1. Okay, we need to add here m plus 1. So left will be m plus 1, m plus 1. Okay, so this will be, m is 5, m plus 1 is 6, so left will be the 6. Okay, so let me draw uh, another. Okay, first here. Okay, so now now left is 6. Now left is 6. Okay, and right is same, no need to change in the right here is 10. Okay, here right is 10, so right is 10. So then what will be the middle? Let me, left, here is the left, this is left, and this is this is right. And what will be the middle? 16 by 2, left plus right by 2, and 16 by 2 is 8. Okay, so 8 is the middle now. So again we need to check, is middle is equal to this number or not? Not currently, no. So we need to check middle is less than this number or greater than this number. So then middle is less than this number, searching number 81. Okay, so we need to search from here, from this point 8 to 10. Okay, we don't need to before 8 index. Okay, we don't need to search. So we need to shift the left, then we need to shift the left. So so let me draw again here. Okay, so now in this case left will be the m plus 1, left will be the m plus 1. Okay, left will be the m plus 1, m plus 1 equal to uh, m is 8, and 8 plus 1 is 9. So left will be the 9. No need to change the right right will be the 10, same as it is. And m will be the left plus right, means 19 here. 19 by 2, 19 by 2 means equal to 9. 9 will be the. So now we need to check left is, now here left is 9, left is 9. Okay, so this is left. Right is also, sorry, means middle is also 9, middle is also 9, and this is right, this is right. Okay, now again we need to check middle. Let me, okay, let me delete this. Okay, this is m, middle. Okay, so middle is equal to this number, search number. Yes, then we need to return the index. Index is, what will be the index? Index is 9. So on the ninth index it will be the number. Okay, and let's the number is, we need to search number is 96. Okay, we found one calculation, but we need to search 91. Okay, so in this case we need to again divide. So paste here. Okay, let's we need to search x. Uh, x is 91 now. X equal to 96. Okay, so here left is 9, here left is 9, middle is 9, and right is 10. and we need to check here the middle is less than 96. Okay, less than 96. That's why we need to shift the left. So left will be the m plus 1. M plus 1. M is 9. The left is m plus 1 is 10. Right, no need to shift. Right is this. Okay, 10. And m, what will be the n? 10 plus 10 by 2 equal to 10. Okay, then we need to search, we need to check m middle is equal to searching word. Yes, so we found by this way. Okay, so let me show you the formula I have written in the Java. Okay, I have an array. Okay, array, we need to find 80. Let me search 81. Okay, we need to find 81 array length. I have calculated if I have created a one method which return the index, uh, found the number and return that index. Okay, if return -1, then no number found, and if not -1, then exact number found at which index. Okay, so what I have using the logic. So this one I have passed array, original array. This is the left, which will be 0, and this is the uh, right, basically the length -1. Okay, so it will be 10, and the x is the searching element. Okay, so first of all, uh, left never greater than right. In this case, we, if left greater than right, then it means number not found. Okay, so that's why we have using the while, and if we are using left less than and equal to right. Okay, because left and right may be equal. Okay, and here we are calculating the m, left plus right by 2, and there is three conditions. First, the middle element is equal to that x searching element. if if equal to, then we will return that of index of middle element. Okay, and if middle element is less than that number, then we need to shift left. Left will be the m plus 1. If middle is greater than the searching word, then in this case we need to shift right before middle. Okay, so m minus 1. Okay, so by this way, if we will run, okay, 81 number found at index 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's check 18. Okay, just run 18 as at 4. 0, 1, 2, 3, 4. Okay, so I have noted here some something like, I'll show you. Yeah, so array must be sorted for the binary search. Need to calculate left and right and middle index of the array. Okay, middle equal to left plus right by 2. If middle less than search number, then left will be m plus 1 and right will be the same, and vice versa here. And left should not be greater than right, so we need to mind these things. So this is the flow. Okay, thank you guys. We will connect with you in another data structure sorting and searching related videos. Okay, thanks.